As we have already discussed, our question that we've been talking about the last couple of days is, what is it that likely caused the extinction of the dinosaurs? Well, one hypothesis is that an asteroid impact is what caused the extinction of the dinosaurs. Now, this hypothesis, though, is just an idea unless we have evidence to back it up. So, if an asteroid impact really did cause the extinction of the dinosaurs all over the planet, there must be evidence left over to show that that is a possibility or something that is true. When you're setting up your notes, you're going to title it Finding the Crater. A crater is an indentation in the earth that would be left over caused by the impact of an asteroid or a large meteor. Or the essential question you're going to write down at the top of your notes is, where is the asteroid that supports the asteroid impact hypothesis? Again, this hypothesis that an asteroid impact is what wiped out the dinosaurs. Well, where is it? And if we can find it, or if we can't find it, is there evidence that we can look to see that it did exist at one point? Set up your notes so there's a columns for terms, notes, and then as we go through the terms, you're going to determine if they are close to, intermittent, that means in between, or distant from a possible impact site where an asteroid might have hit. These are the terms you're going to write in the terms column. There are 8 of them: iridium, ejecta, spherules, tektites, nickel-rich spinels, shocked quartz, breccia, and deposit thickness. Pause this video so you can copy down all of these notes. The first term, well, first, actually, we just need to talk about evidence left behind. So a scientist a long time ago hypothesized that a meteorite or an asteroid struck the Earth 66 million years ago. And again, like I said before, if that's true, then there would be a massive crater and lots of other physical evidence. The evidence that we find is in the KT boundary. Again, the boundary is this impact site, a thin layer of clay that separates the fossils that we find from the Cretaceous period and the fossils that we find in the Tertiary period. Right in between, or on either side of this KT boundary, there's a vast difference of fossils that we find here compared to here. One of the things that we found in the KT boundary is iridium. Iridium is an element that's rare in Earth, but it is abundant in asteroids and comets. Please follow the things that I am highlighting because these are the things that you're going to want to pay attention to in your notes. Well, what we do know is that the asteroid isn't around anymore because it would have been vaporized on impact. If that's true, then we can't look for the actual asteroid, so we have to look for other things, like these fine particles of iridium that would have been distributed all over the Earth. These deposits, or things left over at the KT boundary, hold other clues, not just the iridium. Many KT event deposits worldwide, they have these pieces of melted or crushed rock that were blasted from any impact site. We call these ejecta. These ejecta pieces include things called spherules and tektites. So the idea is that when an asteroid would have struck, some of the rock in the Earth's surrounding crust would have melted, right? You have this gigantic asteroid that's hitting the Earth's surface and then melting the rock that's there. These melted rock particles would have fallen back to Earth and they would have cooled, forming glass-like objects called spherules and tektites. Let's look at those two terms individually. Spherules are glassy spheres, basically little round objects. They're really small though. They range in size of less than 0.1 millimeters up to 2 millimeters. Spherules are found both close to and far from the asteroid impact site. They're found in both places. Tektites, though, are closer to the impact site, so make sure you list that in where they can be found in your notes. Tektites are a little bit larger, 2 to 3 centimeters in size, and they're made entirely of glass. They have irregular shapes when compared to the spherules. These are typically found close to an asteroid impact site. Nickel-rich spinels are also something that have been found in the ground that may give evidence of an asteroid impact. Nickel-rich spinels, it's a type of minerals formed when asteroid material comes through our Earth's atmosphere. These are found all over the place at the KT boundary worldwide. Another thing that's been found, another type of deposit, is a shocked quartz. Quartz is a type of grain or a type of mineral found at the impact site, and what happens is if an impact was hit with an asteroid so strong, it would cause the inside of this quartz to shatter or fracture on the inside as it was blasted into the air. These shocked quartz grains, the bigger ones are really close to the impact size, but smaller ones are found farther away. Another type of ejecta or deposit that's found is called breccia. At K-Tevent deposits, very close to the impact site, we may find large chunks of broken up rock called breccia. Breccia represents Earth's crust that was crushed by the impact site. And again, these are found very close to an impact asteroid site. Deposit thickness. Deposit thickness has a lot to do, or has everything to do with the depth of the ejected deposit. So if the thickness of the deposit is measured, then we can tell whether or not it was close to the KT boundary or far away from the KT boundary. So when you look at this picture, you'll notice that right here, this represents breccia. These little dots here represent a spherule, and the lines here represent the clay in that KT boundary. Well, a scientist would look at the thickness of this deposit to tell how far away this might have been from an asteroid impact site. So, the thicker the deposit of ejecta, the closer the impact site may have been. Here's just a quick review. If something was found close to the impact site, it would have a thicker deposit. It may contain breccia, those rocks, may contain spherules, tektites, shocked quartz, nickel-rich spinels, and iridium. If it's an intermittent distance away from the site, meaning a medium distance away, the deposit thickness would not be that much. It would not contain breccia, but it may contain these other ejecta. If we find some of these things far away from the site, the deposit thickness is not as much. The farther away we get from an impact site, we wouldn't find any breccia, and we might find some of these other ejecta, but those pieces would be very small.